Alright everyone, let's solve this interesting question on the screen. Solution. We are told to solve for x, and the question is 2 to the power of 2x plus 3 to the power of x, all equal to 5 to the power of x. You notice that we can simplify this further. We can break it down using our exponent rule. We know that if we are given a to the power of mx, we can rewrite this to be this same thing as saying a to the power of m, all bracket, raised to the power of x, the law of exponents. So this eventually, the equation will now become 2 to the power of 2 bracket x plus 3 to the power of x equal to 5 power x. When we expand this further, this very one, this is 4 to the power of x plus 3 to the power of x equal to 5 to the power of x. This type of question may be confusing because here we have 3 bases. We have base 4, base 3, and base 5. They are all different. There are no common factors. And here, surprisingly, log trick may not really be easy to clean this up with. So the question now is, what do we do? So if I'm to solve this, which we are already doing, pay attention. I would like to force a 1 into this equation. What do I mean? I would like to equate everything here to 1. And how do I do that? I will have to divide both sides by 5 raised to power x. The equation here will now become 4 to the power of x divided by 5 to the power of x plus 3 power x over 5 power x equal to 5 power x all over divided by 5 power x. Remember what we said, we are trying to equate all this to 1. So this eventually, this here will give us 1 because they will cancel out. Now this will now become 4x all over 5x. 5x plus 3 power x all over 5x equal to 1 because this will cancel this. Recall also that this left hand side, where's my highlighter? Come over here. Okay, let's use this. This here can be broken down into something using the exponent. We know that, recall that a to the power of x over b to the power of x is the same thing as bracket a over b all to the power of x because they have the same exponent. So we can group them and bring out the exponent outside. So let's continue. If we substitute this identity into this equation, we will now have bracket 4 over 5 all to the power of x plus bracket 3 over 5 all to the power of x equal to 1. First, let's see test solutions of x that can give us 1. In order to get this, let us test some values. First, we can say, let x be equal to 1. Let us see if we plug 1 into this equation, whether we can get 1. Therefore, our equation now will now be substituting x to be 1. Will now be 4 over 5 raised to power 1 plus 3 over 5 raised to power 1. Will this give us 1? That's our answer. Will it give us 1? Question mark. Let's find out. This is 4 over 5, opening the bracket, plus 3 over 5. Since they have common denominator, we'll write it and sum the numerator. This is 4 plus 3. This gave us 7 over 5. So therefore, x equal to 1 is not the solution we are looking for. The solution. Let's try the next integer. So what we are doing is that we keep on substituting x with an integer until we get the one that will give us 1. That will make the equation, this our equation here, this equation to be 1. This very equation to be equal to 1. So let's bring down our equation again before I get lost. This is 4 over 5 power x plus 3 over 5. 3 over 5 power x equal to 1. So let x be the next integer, which is what? After 1 is what? 2. Let's find out whether it will still give us 1. So when we substitute 2 into this equation, we have 4 over 5 raised to power 2 plus 3 over 5. 3 over 5 raised to power 2. Will it give us 1? Let's find out. Let's open up this bracket. Let's expand it. This is same thing as saying 4 over 5 multiplied by itself, because it's power 2, over 5 plus 3 over 5 multiplied by itself, 3 over 5. So this will now be 4 times 4 equal to 16 over 5 times 5. This is 25 plus the next one, 3 times 3, 9 over 5 times 5, 25. The same thing we did, we have a common denominator of 25. We'll bring it down, 25. We'll now add this numerator. This will now be 16 plus 9. This is equal to what? 16 plus 9 is 25. 25 over what? 25. Eventually, 25 over 25 will cancel out. This will give us 1. So we can say that the solution we are looking for that will make x equal to 1 is 2. So for this equation, we can say that x equal to 2 works. Did you notice something? Remember Pythagoras? Look at this. Look at this numerator. 16 and 9. And 9. Their sum. The sum give us what? Give us 25. Give us 25. Remember our Pythagoras? This is a classic case of Pythagorean triple. If we have a number 3, 4, and 5, where we say we have our right angle triangle. Come on, my drawing, where here is 90 degrees. This is not drawn to scale. We have that one side is A, the other side is B, and the hypotenuse is C. Pythagoras said that A squared plus B squared will be equal to C squared. If we plug in this into this, where our A will be 3 squared, our B will be 4 squared, our C will be 5 squared. 3 squared is 9 plus 4 squared is 16. You see, 5 squared is what? 25. So See, 9 plus 16 is 25. Now let's have a recap of all we did. Now let's have a recap of what we did. We were given this, and we were told to find x. Find x. This x is same thing. And we said, for us to be able to do this, we have to simplify this equation further. And in our exponent law, we know that a to the power of mx can still be written as bracket m to the power of m to the power of x. In this way, just writing it, commutative law of multiplication. One thing with multiplication is that no matter the direction you choose to multiply, you will still get the same value. This is just like writing this to be in this form. It's still the same thing. So we now state that our new equation will now become what? 2 to the power of 2 bracket x plus 3x, 3 to the power of x equal to 5 to the power of x. The reason why we did this was what? For us to have what? Common power or common exponent. For it to be easier to solve. We brought it down here. This is 4x. After simplifying this is 4x plus, we brought this down, 3x, 3 power x equal to 5 to the power of x. We now said, how can we equate this solution, this equation to 1? We need to force 1 to introduce 1 into this equation. We now have to divide both sides by this to clear the right hand side. When we divided both sides by 5 to the power of x, here we got this, and this gave us this. This is 4 to the power of x, 5 divided by 5 to the power of x, plus 3 to the power of x divided by 5 to the power of x equal to 1. Because we wanted to equate everything to 1. We said that if you recall our exponent law, that this can still be written in the form of this, since they have the same power exponents. So writing this equation, writing our original equation, give us what? 4 over 5 all to the power of x plus, same thing, 3 over 5 all to the power of x equal to 1. We now said, let us start imputing integers from the first two. We are able to get a value that will give us 1. First, we said, let x be 1. We substituted x to be 1, and we got this, which did not eventually give us 1. Rather, it gave us 7 over 5. So we said that 1 is not the solution we are looking for. It's not the solution we are looking for. So we said, now let's try the next one, which is 2. So when we substituted x to be 2, it gave us 1 eventually. And that became the solution that we are looking for. I always said that if you paid attention, that Pythagorean triple appeared in our solution. We look at 9, 16, 9, and 25. Pythagorean is like, these are perfect squares, right? This is 4 squared, this is 3 squared, this is 5 squared. So we said that we can write this to be 4, 3, and 5 using Pythagorean theorem, where the basis can be 3 will replace A, 4 will replace B, and 5 will replace C. And we're able to get 25. This is just to prove that this is a Pythagorean triple. But our main solution to this equation that made the equation work is 2x equal to 2. So if you paid attention up to this level, thank you. We appreciate you. If you're a returning viewer, we thank you for that. If you've not subscribed to this channel, please kindly click on the subscription button, the notification bell, so that you'll be notified when the next episode drops. Thank you, and see you on the next one.